All right, so this example 6, this is how you would show um, using algebra, okay, doing an analytical analysis um, of limits at infinity where you don't have the graph. All right, so I give you the graph off to the side for the notes, that way you can kind of see, but in like an open response or something. If it says to show an analytical analysis, kind of explaining, like in part A, about the ratios, that's not going to work, right? Because if you start to explain what's happening on the graph, that's a graphical analysis. So if it's not specified, you can use this. So I know right off the top that the answer to this one is going to be 2. Right, because the powers are the same. So we take the ratios of the coefficients, which tells us where the horizontal asymptote is, and we're looking at infinity, so I know the answer is 2. Right, but I wouldn't be able to write that in words on an open response on the AP exam. All right, so if you have to show the algebraic analysis here, we basically are going to divide every term by the highest power that appears in the denominator. All right. And then essentially we're going to throw in infinity, and then things will cancel to 0, and then you'll end up with 2 at the end. All right, so it's nothing difficult. You just have to know how to handle it. Okay, so the big thing is when we try to throw in infinity, we're going to end up with something like this. Like in the function, we're going to have to do like the limit as x goes to infinity of 8 over x. Okay, this is basically like 8 over infinity, which is going to equal out to 0. Okay, so I'm going to do that a lot. Anytime that you have infinity in the denominator, when you're taking limits, it ends up going to 0. All right, so the first one's going to look like this. It looks a little weird at first, but there's nothing difficult at all. All right, so the limit as x goes to infinity, we're just going to take the highest power in the denominator, like that highest term, which is x squared, and divide everything by x squared. So the first one, we'll divide it by x squared, and then the 10x squared, and then in the bottom, divide this by x squared, plus 15x squared. Okay, and then we just clean it up using properties of exponents. So at the top, let's see, this is going to go to what, 2? Over here, if we have 10x over x squared, that just becomes, what, 10 over x? This would become 1. This would become 8 over x. And then nothing would change for the 15x squared. Okay? So now comes the evaluation step. So I'm basically going to throw in infinity wherever I see the x. And we know that that's going to end up collapsing to 0. So in the first part, like in this term, that just went to 2. And then this second part, we'll do that in purple, that's going to collapse to 0 because we have 10 over infinity, which is just going to end up being 0. So it's like 2 minus 0 at the top. And then in the bottom, just write it like this. The first term went to 1. And then 8 over x, like this term right here, ends up going to 0 because we're just throwing in infinity. And then same thing for the last term. So 15 over infinity squared is just going to be 0. Okay, so this would, of course, go to 2. All right, so that's the idea. When you have to show algebra, take whatever the highest term is, all right, in this case it was x squared in the denominator, divide all the terms out, and then everything kind of cleans up really nicely. Okay. All right, so let's see. So we know that the answer is going to be 0 in part B just by looking at it, because we're checking as you go to infinity. And then the powers, we have the power of 1 at the top and power of 2 at the bottom. So we know that this is going to be collapsing down to 0. And that's exactly what's happening on the graph. All right, there's an asymptote at y equals 0. Okay, and we did the graphical analysis already. Algebraically, we're just going to have to divide everything by x squared and clean up the function here. So we'll do x divided by x squared plus 3 divided by x squared all over x squared plus 4x over x squared plus 5 over x squared, and then we'll see what's going to happen over here. So this would simplify to 1 over x This doesn't simplify, 3 over x squared. This would simplify to 1. This would be 4 over x. And then the last term doesn't simplify. All right, so now we're just going to throw in infinity. The first term, 1 over x, or 1 over infinity, now is 0. Same thing at the top, 3 over infinity squared would become 0. At the bottom, it becomes 1. And then plus 0, because it's 4 over x. And then 5 over infinity squared is also 0. Okay, so this becomes 0 over 1, which is just 0. All right, it's just a matter of dividing by that term and then cleaning it up, right? Nothing crazy. So right here, I know the answer is infinity just by looking at it, because we're looking at infinity and the power is higher in the numerator, and then that is what's happening on the graph. This one has a vertical and an oblique asymptote. And what are we looking at? Infinity. So it's going to happen very slowly, but eventually this is going to be shooting to infinity if we imagine it going on forever. Oops. All right, so we're just going to divide everything by x. So we have x squared over x minus 4x over x minus 3 over x over x over x minus 2 over x. All right, that was the highest in the denominator. So this would go to 1 over x. This would go to 4. And then eventually this is going to go to 0. This would go to 1, and then eventually that'll go to 0 as well. Okay. So if we clean this up, well, that first one doesn't go to 1 over x. I'm sorry. X squared over x is just x in and of itself. I apologize. So x squared over x is just x here. All right, so at the top, if I was to start to throw in infinity, we have infinity minus 4, and then minus what ended up going to 0 over 1 minus 2 over infinity is just 0. So this just becomes infinity.